Hi, welcome back. Hearty welcome to you. So we are solving some examples as part of mathematical induction. So let's go ahead and try to solve this problem together. We have to prove 1 by 1 into 2 into 3 plus 1 by 2 into 3 into 4 plus 1 by 3 into 4 into 5 up to n terms, where nth term is nothing but n into n plus 1 into n plus 2. The sum of this is nothing but equal to n into n plus 3 by 4 into n plus 1 into n plus 2. So we have to prove this. So we'll go ahead with proof by mathematical induction. First we have to prove that this is true. LHS equal to RHS for n equal to 1, a specific value. Then we'll assume that this LHS is equal to RHS indeed for n equal to k. Then we'll prove based on that it's true for n equal to k plus 1 also, which proves that for any value of n which belongs to natural numbers, this expression is true both on left hand side and right hand side. The equation is true. Let's go ahead. Okay. So step 1, for n equal to 1, LHS is equal to 1 by 1 into 2 into 3, that's nothing but equal to 1 by 6. RHS equal to n, that is 1, into 1 plus 3, that is 4, divided by 4, into 1 plus 1 into 1 plus 2, that's nothing but equal to 1 into 4 by 4 into 2 into 3. 4 cancels out, that's nothing but equal to 1 by 6. So LHS equal to RHS for n equal to 1. Now let's go ahead and go to the step 2. Assume that it's true for assuming LHS equal to RHS for assuming true. What's true? LHS is equal to RHS. For n equal to k, we'll have 1 by 1 into 2 into 3 plus 1 by 2 into 3 into 4 plus 1 by kth term will be, you can see here in the first term you are starting with 1, then 2, 3, that's nothing but you are increasing. So it will be similarly k plus 1, k plus 2, or you can directly substitute n equal to k in the nth term. This is nothing but we are assuming that it's nothing but equal to k into k plus 3 by 4 into k plus 1 into k plus 2. This is what we have assumed. Now based on this we have to prove that it's true for n equal to k plus 1. So let us see how it looks like. What we have to prove for n equal to k plus 1. If I go for k plus 1 terms, it looks like 1 by 1 into 2 into 3 plus 1 by 2 into 3 into 4. Then I'll have kth term, because k plus 1 comes after kth term. I'll have kth term, that is k into k plus 1 into k plus 2. Then I'll have k plus 1th term, that's nothing but 1 by k plus 1 into k plus 2 into k plus 3. This is nothing but equal to, I have to prove that this is nothing but equal to k plus 1 into k plus 4, because I have to substitute n equal to k plus 1. So instead of k, I will be substituting k plus 1. K plus 1 into k plus 4 by 4 into k plus 2 into k plus 3. This is what I have to prove. So what I will do now is, I know already the terms from here to here, nothing but sum of the k terms is nothing but equal to the RHS value whatever we have assumed. So I can write it as this whole thing from first term till k term, sum of that I can write it as k into k plus 3 by 4 into k plus 1 into k plus 2. Now we are starting from LHS for n equal to k plus 1 and we want to prove that that's equal to RHS. Then we have proven for any value of n, LHS is equal to RHS. Okay. Now what is the, we have replaced this whole thing with RHS of n equal to k. Now I have to add the k plus 1th term. What is k plus 1th term? 1 by k plus 1 into k plus 2 into k plus 3. Now let's take LCM of this. If I take LCM of this, I will have 4 into k plus 1 into k plus 2 into k plus 3, and I will have in the numerator k 4 into k plus 1 into k plus 2, then I am remain with k plus 3. This becomes k into k plus 3 whole square plus, if you take the second term, everything is there other than 4, so I will have another 4. This is nothing but equal to, now you can, actually I can multiply this k into k square plus 6k plus 9. So I'll write another step here, that is k into, if I expand this is nothing but equal to k square plus 6k plus 9 plus 4 divided by 4 into k plus 1 into k plus 2 into k plus 3. This is nothing but equal to k cube plus 6k square plus 9k plus 4 divided by 4 into k plus 1 into k plus 2 into k plus 3. Now we have to find out the factors of this, but if you see what we need to have in the denominator is 4 into k plus 2 into k plus 3. That means k plus 1 should be factor of the numerator. And also you can check here, if you look at this expression k cube plus 6k square plus 9k plus 4, you look at all the odd positions. 1, let us say that you look odd like k cube and k, you see that they add up to 10. Similarly, even numbers also add up to 10. That means k equal to minus 1 will make this as 0. That means k plus 1 is a factor. So I can write it as, I will show you again how I can do that. But I can write it as k plus 1 into k square plus 5k plus 4, k plus 1 into k square plus 5k plus 4 divided by 4 into k plus 1 into k plus 2 into k plus 3. Now you can cancel k plus 1, and what we will have at the end is nothing but, I will have k square plus 5k plus 4, which I can write it as k plus 1 into k plus 4, that whole thing divided by 4 into k plus 2 into k plus 3. That's exactly what is the RHS. Now let us look into this one, k cube plus 6k square plus 9k plus 4, and we got our answer. I just want to spend couple of minutes on how we got this to here. So k cube plus 6k square plus 9k plus 4, let's do it here. K cube plus k cube plus 6k square plus 9k plus 4. Whenever you have to find out factors for such a polynomial, what you do always is check whether check whether if you add all the coefficients whether it is becoming 0. If all the coefficients, if you add it's becoming 0, then k minus 1 is a factor. If you add alternative positions and try to add them up and see whether it's becoming 0, if it is, then k plus 1 is a factor. Now here you can see k cube is 1, k square is 6 quotient, k is 9 and constant is 4. You can see that this plus 6 plus 4 is equal to 9 plus 1. So k plus 1 is a factor. K plus 1 is a factor. Now how to find out? For that I can do two ways. I can actually, what I can do is I can do by division, and also I can do by trial and error, because I know I should have k cube, that means first term should be k square, and I should have 4 at the end, so the last term is 4. In between I can manipulate what should come, but I will go by division and show it to you. If I take minus 1, then I will have here 1, 6, 9, 4. First I have to put 0 here, then I will have 1, minus 1, 5, minus 5, 4, minus 4, 0. So k cube plus 6k square plus 9k plus 4 is nothing but equal to k plus 1 into k square plus 5k plus 4. But k square plus 5k plus 4 is nothing but again equal to k plus 1 into k plus 4. That's how we have found the factors of that. So what we have done is we have started with n equal to 1. We have proven it. Then we have assumed for n equal to k. After assuming for n equal to k, based on that we have proven that LHS is equal to RHS for n equal to k plus 1. So see you in the next video, where we will do some more examples on mathematical induction. Thanks for visiting. Bye for now. Catch you.